Greetings to everyone. First of all, we would like to thank the Symposium organization for the opportunity to present our work in this event. Also, we would like to acknowledge the participating institutes, the International Energy Research Centre, part of the Tyndall National Institute, and the University College Cork, Ireland, the University of Technology of Troyes, France, and the Polytechnic University of Milan, Italy. Finally, we also would like to thank the support of the Department of Business, Enterprise and Innovation via its Disruptive Technologies Innovation Fund, DTIF, under the Government of Ireland's Project 2040 plan. My name is Fabio Silva from the International Energy Research Centre, part of the Tyndall National Institute and the University College Cork, Ireland. My co-authors and co-workers are Brian O'Regan, Karen Mood, and Patrick Leon from the same institute. Finally, Castro Soares is the co-author from the Polytechnic University of Milan, Italy, and Milagre Magnic is the co-author from the University of Technology of Troyes, France. In recent decades, the transition from fossil fuels to the use of renewable energy sources has profoundly changed the world's energy landscape, giving rise to the concept of the transition based on the principle of the 3Ds: decarbonization, decentralization, and digitalization. The emergence of the concept of community energy suggests a fourth D, democratization, as a pillar underlying the concept of community energy, in which energy is produced by and for the community, placing the citizen and community at the center as key actors in the entire energy value chain: generation, distribution, consumption, and associated services. However, the global energy landscape is not uniform in terms of access to energy sources, and this debate in developing countries is still relevant. A significant number of citizens do not have access to electricity in the first place, and are still seeking access for it for the very first time. In other words, energy inclusion. Case study. Now we will present a high-level case study from Mozambique to demonstrate how renewable energy is addressed now, some of the most common problems, a few examples of the benefits the energy community can bring, and finally, a more detailed comparison between community ownership and government ownership paradigms. Usually, government initiatives to promote renewable energy in remote areas have fragile policies and infrastructure in place. Inefficient technical and technological capacity, as well as the lack of qualified manpower to design renewable mini-grids, can lead to the poor evaluation of proposals submitted by private companies during the public tender. Also, it's commonplace the lack of transparency in these proposals, and in the end, what happens is that we have ineffective technical proposals and or poorly dimensioned systems. As a consequence, more than 50% of the mini-grids are not working properly. For example, demand peaks can be higher than the capacity of the mini-grid, or you can have oversized systems that waste energy. Another example would be concurrent power generation sources that have no agreement to inject renewable energy into the main grid. Or the case of a minor hydro plant installed without backup systems, which makes it useless during the dry season when we have no water. Also, when the national grid reaches the small village, the minor hydro will most likely be abandoned. If such problems can be addressed properly, several benefits can be achieved. One of the most direct development impacts is job creation. both temporary employments during the construction phase and permanent employment during operation and maintenance. In similar studies in India, agricultural applications for mini-grid electricity have proven benefits. Mini-grid electricity reduces the cost of irrigation by 70% and improves the productivity of rural enterprises by 50%. Also in India, well-lit households in the community improves women's safety. Close to 87% of women feel that their mobility has vastly improved after dark because of well-lit surroundings. Lighting and mobile phone charging allow longer studying hours for children. Monitoring data since 2015 indicate children's after sunset study hours increased an average of 30 minutes. Mini-grid electricity also improves health services. Close to 70% of households reported that mini-grid electricity has helped health facilities expand their working hours and reduce noise pollution caused by diesel generators. Finally, mini-grids can reduce carbon emission significantly. The next slides will bring brief high-level examples of the advantages of the community ownership promoted by the energy community in comparison with the government ownership currently in place. In what concerns social development, the community ownership promotes a broader distribution of the benefits. For example, giving higher importance to gender-sensitive problems and a more democratic use of energy based on the multi-stakeholder participation. On the other hand, the government ownership is limited by issues related to imbalance and conflicts in the access to energy. In the environmental aspect, as the community implementation can be more effective, the climate mitigation aspects of its use are maximized, while government actions are negatively impacted by waste of resources due to poorly designed projects, both in technical and policy aspects. Also in the economic aspect, the community initiatives can be more efficient, cost-effective, and grow organically. Government initiatives are limited by insufficient private sector investments and poor planning, leading to higher costs per kilowatt. The technical aspects of such projects can also benefit from the community ownership approach that can promote higher reliability, flexibility, and efficiency. Finally, in the governance aspect, the community ownership brings the empowerment of the local communities, local authorities, and the citizen to enable energy democracy and inclusion. Now we are going to discuss our suggested approach for the implementation of a community energy based on a modular and cost-effective approach. Also, we will introduce the Sense Cooperative Platform, designed to, amongst other features, to support community energy implementation and growth. The Sense platform enables both individual consumers and their communities to generate their own electricity and provides a blockchain-based platform to trade electricity based on a cooperative model. Sense significantly improves the traditional electricity market model, but also aims to coexist with the current market. No disruptions in order to guarantee that the community energy can be integrated into the traditional grid and preserve the investment. It also provides the means for the establishment of the relationship for peer-to-peer energy trading or otherwise, for example, surplus generation donation or any energy poverty policy in place, through the flexible and adaptive business model parameterization. Additionally, Sense provides support to regulatory strategies, policymaking support, and proposes necessary hardware requirements. With the support of the Sense platform, an innovative modular approach is possible. Based on typical components, we suggest new innovative modular ways of implementing distributed energy resources based on typical photovoltaic panels and energy storage. A modular approach for the implementation of smart grids can promote a more cost-effective organic growth, distributing resources more evenly, and avoiding oversizing or undersizing of electrification systems in both rural or urban areas. Such implementation empowers the customers in the figure of the prosumers, individuals who consume and/or produce electricity, and now can trade or donate the surplus generation at their own convenience. Consequently, the community where the prosumer chose to participate is also empowered by its participants. The community energy becomes then a reality. Such modularization would also allow new partners or new equipment sets to be added to the infrastructure smoothly. An isolated potential prosumer would not be able to trade its surplus generation in a manageable way, as it would lack interconnection infrastructure and appropriate tools to help it define when and how much electricity should be sold or traded. As more prosumers or consumers are added to the community, it becomes clear that the trade opportunity can be a valuable asset in several aspects. Again, the Sense platform provides the infrastructure for the establishment of the community energy, covering several important aspects such as hardware interconnection and IoT, integration management, business model parameterization, trading infrastructure tools, and the data-driven policy support. New prosumers can be added smoothly, and the platform can be set up to adapt to local regulation and different local demands. Such modularization is only possible through the Sense AI-based smart grid management. It can add new partners to the infrastructure and also optimize the relationship between prosumers on whatever business model defined on the relationship. Additionally, it can reduce operating and maintenance costs of the system and balance generation and consumption. Conclusion. With all that, the suggested modular implementation in conjunction with AI-based smart grid management will provide smart grids that can tackle the challenge of reducing costs of investment and develop a fair consumption and generation balancing scheme that, with time, can promote local sustainable industrial and human development in a virtuous circle to boost social transformation. In the community energy, the energy is produced by and for the community. It engages the citizen and the community as key actors and impacts the entire energy value chain. Finally, by promoting energy democratization, it strengthens the concept of community energy, increases the socioeconomic empowerment of the involved prosumers, and achieves energy inclusion. Thank you very much for your time and patience. Feel free to contact me at any time if you want more details. You can use my personal contact details, or you can scan the QR code for our website. Once again, thank you so much.